of you. So today we are going to have a pre-recorded lesson and let's begin. Okay, so now what we're going to do is that we're going to do a quick recap on what we have learned. So yesterday we learned that electricity is very dangerous. It can shock a human to death. It can cause electrical burns. It can also cause electrical fire, like how our personal mobility device catch fire and things like that. So there are safety devices to actually help us mitigate the risk of having all these hazard like shock or fire. So we have learned quite a number of safety device. Currently there are 4 of them. One of it is on this picture, and in fact 2 of them are in this picture. So which are the 2? Yep, remember about the longest pin, why the plug has 3 pins, one of the pin is longer than the rest. Yeah, I'm referring to this particular pin that is on top. So this pin, it is very long so that it will engage first with the socket, which is basically what you see on the wall. So this longest pin is connected to the earth wire. So the earth wire is actually one of the safety devices that we have. We are going to talk about it later in greater detail in this lesson. So the earth wire, we have also learned how do we identify the wires, because basically wires are just copper and they all look the same. So we basically have a plastic webbing around the copper wires, and earth wire will have this color code yellow and green, as you can see over here. Oops, not responding here. Yeah, yellow and green. So it is in strips of yellow and green. When answering question, you need to spell it out and give me the complete sentence. The other thing that the other safety device that you can see from this picture is actually this thing over here. This is what we call a fuse. So we are also going to talk about this in greater detail today. Okay, so besides safety devices, we have also learned about that the live wire is brown in color, it has high voltage. So when we say that something is having a high voltage, what is the vocab that we use it to describe that? It has 4 letters. So if you have forgotten, it's okay. The live wire has a high voltage. And what is that wire called? Live wire, right? So basically anything that has high voltage, we will just call it live. Yeah. And besides the live wire, we also have the neutral wire, which has 0V. That's why it is blue, is safe to touch. Okay, the earth wire is also having 0V. So basically there's only one thing that is alive inside your plug, and that is your live wire. So since we are on the topic of live, high voltage and all that, let's go back to the basic and revisit some of the concepts. So let's open this. Okay, the question I want to check with you is that, okay, live means that it has high voltage, right? Does it mean that it has current? Having a high voltage, does it mean that it has current too? So take some time to decide on an answer, yes, no, but don't guess. Try to form a explanation in your head as well. Okay, I hope you have something in your mind. So, have you ever seen in cartoons whereby, you know, those cables that are on the that is not buried, they are being mounted on a pole, something like that. Oops, by a pole like that, and then on this side there's another cable down here. Then sometimes you will see that in the cartoon there will be like a bird standing on the wire, like that, and then the bird is alive, kicking, and they are okay. So why is it that the bird can stand on one wire and still be alive? Some of you may say that, oh, maybe he's standing on the neutral wire. Then how do the bird tell that it is a neutral wire? If the bird cannot tell, that means you would, if it is seated on a live wire, would you see like a lot of dead birds hanging over there? No, right? So actually, even if this wire is live and the bird is resting on it, the bird will survive. Why? It is live. It is very, very high voltage. It could come into a few thousand. So why is it that the bird can survive? Now, like I said before, what is killing us is actually the current, it's not the voltage. So when this bird is seated on one wire, and even if the wire is exposed, he's fine. So this wire has 240 volt. So let's say there is direct contact between the bird and this copper wire. The left leg of the bird will have 240 volt. The right leg of the bird is also on the 240 volt wire. So if both sides are 240 volt, is there any potential difference inside the bird? No, right? And we have learned in our earlier chapter that the current will only flow when there is potential difference. For example, when you put a battery, the positive terminal will have 3 volt, the negative terminal will have 0 volt. So 3 volt, 0 volt, there's a potential difference, there will be a current. So for a bird to sit on a live wire, both the left leg and the right leg will have the same potential difference. And so the bird will be very happy and she will not get burned, or the bird will not get electric shock. But if now I change the context from a bird to, let's say, what animal should we use this time? Let's say we use a monkey. Okay, let's draw a monkey. Okay, it is a ugly monkey. Okay, very naughty one. Okay, and this monkey is holding onto just the live wire. Will the monkey die? No, right? Because his left hand is 240 volt, right hand is 240 volt. He's fine. He will be happy and kicking and throwing stones onto the passerby. But what if now we change the context and this monkey is now holding onto another wire like this? So one hand he's holding onto the 240 very high voltage live wire, and then the other hand, after you have the live wire, what is the other two wire? One will be earth, the other will be neutral, let's say. So let's say this is neutral, and neutral wire will have 0 volt. So now one hand 0 volt, one hand very, very high voltage. Will the monkey die? Yes, right. So now with this, I would have a high voltage here and a low voltage here. There will be a potential difference, and then a current will flow through the monkey and thereby killing the monkey. Okay, so what we have learned here is that by saying that something is live, it means that it has high voltage only. Does it mean that there is current flowing in it? No. Unless if there is a potential difference, then a current will flow, and it is mostly the current that will kill us. Okay, so let's now go back to our worksheet. Okay, and let's skip the last question of page 2. Let's go to page 3. Let's talk about our fuse. Okay, so first of all, you need to know the electrical symbol of a fuse. Electrical symbol of a fuse looks like this. Okay, so the first question is that I need to connect the fuse to the circuit. And we have learned from the front that the fuse, which is here, let's erase some of this highlighting so it doesn't look so colorful. So we learned that the fuse is connected to the live wire. So now down here, where is the live wire? Okay, L stands for live wire. So this entire thing is live wire. Here comes the question. Should you connect before the switch or should you connect the fuse after the switch? So if you remember, where is our fuse? Our fuse is actually inside our plug, right? So imagine you have appliances, for example, a lamp on a nightstand, and then okay, you have the IKEA cover as well, the lamp and all that, right? So you will have your live wire going like that through the wire, and then you will have your plug, and of course you will have your neutral wire also like that, right? Yeah, where is the fuse? Oh, where? Oh, then there will be a switch over here, maybe can be here, there may be a switch. So where's the fuse? The fuse is normally over here. Now why is it that you want to put your fuse over here? Because number one, this one you may want to write it down, the fuse is near the power source. Because why? It is easy to change. Now why is it an advantage for a fuse to be easily changed? So now I'm going to show you how does a fuse look like. So let's go here. So this is basically a fuse. It has two terminals, the metal part, left and right, and in between, basically it is just thin wire. So as you can see in the top left hand corner, now we are passing through a current of 1 ampere through the fuse. Now I want you to pay attention as the ammeter show a larger reading. What happened to the fuse wire in the transparent tube, which is the fuse? So now the current is rising, 2 ampere approaching, 2 ampere now. Can you see the fuse wire become pinkish, become red, bright red, and so what happened just now down here? Very red, right? Then after that, basically, if you look at the left hand side of the fuse, you can see that there's a tiny gap. So what happened is that the fuse wire melted, and then when it melted, it breaks off and it opens the circuit, and then it cuts the current, because in order for current to form, there must be a complete loop, right? So this is what we call the fuse wire melt. So once the fuse wire has melted, can the fuse be reused? Can you reuse this fuse after the fuse wire melt? The answer is cannot. Once the fuse wire is melted, you need to replace the entire fuse. And that is also the reason why you want to put the fuse outside the appliances, so that when the fuse blow, you don't need to open up the casing of, imagine your fuse is inside your laptop. You need to open up the entire laptop, change the thing and all that, right? It's very troublesome. But if you put the fuse inside the socket, like what I did yesterday, I just need to get a screwdriver, open up the plug, replace the fuse. So let me show you how that looks like in a later video, okay? So another advantage of placing the fuse near here is that if the fuse over here were to blow, then the entire part of the appliances over here will be safe to touch. Okay, let me show you what I mean. So first of all, now you know that the fuse should be here in front of the switch. So let's draw this here. Now before I move on, I want you to imagine that something were to happen. There's a large current flowing through, and now your fuse will break. Okay, so when your fuse break, this part of the wire will be 240 volt. How about the rest of the circuit? The rest of the circuit, because down here, now that your fuse has blown, the rest of the circuit here will be 0 volt. So if you want to change the light bulb and you touch it, you will be safe. But if now I put my fuse elsewhere, so let me draw a diagram when the fuse is elsewhere. This is the casing. Okay, then I have a switch. Like that. Okay, now what happened is that I want to put my fuse, say, over here on the neutral wire, and something go wrong and my fuse blow. So when my fuse blow, will there be any more current? No current, because it is an open circuit, right? Let's say I close my switch and all that. Yeah, so when I close my switch, something went wrong, my fuse wire melt, it will become an open circuit. So it will become something like this, right? So now this thing become like that. It is open because my fuse has melted. Now I want you to trace where is the 0 volt, like what I did over here. Where is the 0 volt and where is the high voltage part? Take some time to think. High voltage come from the live wire, so I trace here, here, here. So the yellow part, all these are high voltage. Where is the 0 volt? 0 volt from neutral wire, here to here. Meaning that when your fuse wire blow in this case, and if you are the unfortunate people, you want to fix this, and you put your hand over here, you are actually touching something that is live, meaning a high voltage, and you are standing on the ground. When you're standing on the ground, you are at 0V. So when that happens, you have a potential difference between your hand at 240V and your feet at 0V. So a current will flow through you and thereby kills you. So that's why when you want to install the fuse, you have to always install it on the live wire. Okay, similarly, if now I have another case, I decided to install my fuse here. It's on the live wire, but not as close to the power source as case 1. Which are the part that is live? Here, here. When the fuse blow, only the yellow part is live. The rest will be 0V. So this is still kind of safe, but if you are an unfortunate person and you decided to touch this part, then what will happen to you? You will die again, right? So in order to be very safe, you should you should put your fuse as near to the live terminal or the live socket as possible. Okay, so let's look at this. How does a fuse act as a safety device? This one you need to memorize because you need to know how it works. I have shown you the video on how the fuse works. Basically, the fuse wire will melt Please don't say that the fuse melt. The fuse cannot melt, only the wire. So when the fuse melt, it opens the circuit. So this is to put that in words. So we say that when a current is larger than the fuse rating, so in your fuse, there's a fuse rating. How does that look like? Let's take a look. Let's see fuse. Yeah, so let's open the image. Okay, down here, can you see? This 13A is what we call a fuse rating. It means that as long as the current is below or same as 13A, 13 ampere, the fuse wire will be okay. It will let the current flow. But what if you get 13.2 ampere? Once you have a current larger than 13A, then the fuse wire will melt and then it will protect your circuit. Okay, so that's your fuse rating. What does the fuse do when triggered? Well, when the current is larger than the fuse rating, then the fuse wire, not the fuse, the fuse wire will melt. And what does it do? It opens the circuit. So because of that, once the circuit is open, it basically protects your appliances from high current and any possible electric fire. Okay, now here comes the question. Okay, that is how the fuse work. I understand when there's a current that's large enough, the fuse wire will melt, and then the circuit will be open, and then everyone will be happy, and nothing will go wrong. But can I ask a question? How come the current will be suddenly so large? You mean someone will be stupid enough to put like 10,000 battery in series and then just chong the current? Why will there be a large current? Why will there be a large current? Well, it can happen two possibilities. One is lightning strike. When the lightning strike the lightning pin on your house, the large current can surge into your power grid, and therefore a large current will go into your appliances. And then that's why sometimes in a stormy night, if you are living in Malaysia, when there's a huge storm coming, you will see that suddenly your house blackout because that lightning strike into the power grid, and then the large current will flow through your power grid, and then it will trigger the fuse. Sometimes it triggers the circuit breaker, things like that. Another reason that is more common is that due to wear and tear, sometimes, I'm answering this question, sometimes the live wire can cut through the plastic wrapping and it will connect to the casing if it touches. So when this happens, it will look like this. You have a power source, and then in one branch it connects to the bulb, which is this branch over here, and then because of the wear and tear, it touches the metal casing, right? And a metal casing basically is a very low resistance thing, right? So this is your metal, correct or not? This is your metal casing. So we know that your light bulb or whatever will definitely have high resistance, and then your metal casing will have low resistance. So when a current flows through the live wire and to here, it will have a junction and it has a choice whether to flow through something that's high resistance or whether to flow through there's something that's of low resistance. And of course, current will always choose the low resistance path. So look at this, V equals to IR. Your V is constant because the PD across a parallel connection is the same. If now your R is really small, then what will happen to the I? The I will be very big. What do I mean? For example, if my V is 240 and my R is 0.01, what will be the current that will flow through? It will be 24000, which is a huge current. So this thing that branches out like that, when I have a very low resistance path, this is what we call a short circuit. And it is due to a short circuit that a large current will flow through, and then it will blow the fuse. Okay, so this is your part C answer. Okay, you can just branch out like that. Can? Now in some N-level question, they will also ask you, what kind of fuse should you choose? So let's say you have a light bulb that draws 3 ampere. What kind of fuse should you choose? 1A, 3A, 5A, 7A, 13A. Most of the time, we will just choose a rating that is slightly higher than the operation current. So we will pick a fuse rating that is slightly larger than the operating current. What is the operating current? This one, no? Can? So down here, question 7 is what we have done. What is the difference between connecting the fuse on a neutral wire? Well, the problem is if you put your fuse on a neutral wire, then this entire part, then this entire part will be live. This entire part, and that is dangerous because you may touch it. So let's read this question. Okay, so I have a electrician connected the fuse on a neutral wire. Okay, and the switch is closed, and then there's a fault. This is the fault. It is a short circuit, right? This one is a short circuit. Why is it a short circuit? When your current goes like that, the current will choose to flow here. And you can see this green path has 0 resistance. So the current will be huge. So that's why you call it a short circuit. Okay? And when there's a short circuit, of course, your fuse will blow. Your fuse wire will melt. So let's see what will happen to this. Okay, so part B, let's answer. Why is it less safe? So when the fuse wire melt, circuit will open like this. It is open, and so there will be no current flow. However, if you look here, this is 240V. From here all the way till the part whereby the fuse breaks, which is here, the yellow part, all this yellow part will be at 240 volt, meaning live. And if some unfortunate person were to touch the yellow part now, he is standing on the ground, he will be 0V. So if he go and put his finger here, it will be 240V and his feet at 0V, so a current will flow through him and kills him. So that's why putting a fuse on the neutral wire is a bad idea. So that's why down here, it will remain live. Hence, if the person touch the yellow part of the circuit, the person will be shocked. And hence, it is not safe. Okay. So down here is just another illustration to show you why is it important to actually put the fuse as close to the live terminal as possible. So down here, where is the live part? Here. I mean, after the fuse blow, then this part will be live, while the remaining of the circuit will be safe to touch. If you go and put your fuse over here, and let's say the fuse blow, then this part, it is still live, and only this is neutral. So as you can see, by putting it here you got a larger part of the circuit that is safe to touch. Yeah, so that's why here is larger. Can. So I think now I will pause over here because it is quite a lot to digest, and I will just want to show you how the fuse actually look like in a plug. So give me a minute. Okay, so this is a fuse. As you can see, it has a fuse rating of 13 ampere. So how does this fuse work? Can you see this pin? This is the pin whereby the electricity will go in. Once it go in, it will go into the bottom of the fuse. So the current need to go through the fuse wire that's inside before it can transmit the electricity to the brown wire. So down here you may say, hey, there's a gap there, how do you transmit? So what you do, down here all these pin, right, you can push it up. Okay. Wow, very tight. Okay, this one you can push it up. Yeah. Here you can push it up. So I push the pin in and you can see. So you can take this out. So that's how you change the fuse. Okay, you can change the fuse like that. Yeah. Then down here, this is how, if the fuse is inside, right, then down here, this part will touch this part, go through the fuse wire to here. This part, can you see this copper plate is linked to the metal? Yeah, and then from the metal it has this brown wire and goes down. So this is how it works. Can. So I will stop here, and I will see you again. Okay, bye bye.